Hello, welcome back. This is the second part of our first lecture. In the first part, we talked about computer hardware. Now we'll start talking about computer software, which is going to be our main interest for the rest of this module. All right, let's start. So, computer programs, they're also known as software, are instructions that tell a computer what to do. So we are going to tell the computer, so for instance, step 1, so this is your job, open a movie, and for instance, maybe step 2, after you watch it, play the movie, and then step 3, close the movie. So this is a computer software that lets you open a movie on your computer and then play it for the while you watch it and then close it after you've finished watching it, right? So these are the 3 instructions that we tell the computer to first start the movie, open the movie, and then play it for a while and then stop it, right? So this is the entire thing is called a software or a computer program. So in this class, we are going to learn how to write a software program, a computer program, a software like this. Maybe not exactly like this, but similar to this, right? So without programs, without software, the computer is actually an empty machine. And we are going to write the programs using programming languages. In particular, we are going to use Python in this module, but there are also other programming languages that, for instance, some other schools might teach, I don't know, Java, C++, but in Tilburg, we teach Python. And there are 3 types of programming languages: machine language, assembly language, and a high-level language. All right, so let's talk about the machine language first. So machine language, we are not going to use it. So it is actually very difficult to read and write a machine language computer program because the instructions are in the form of binary code. What do I mean? For instance, your first instruction might look like this, like 1 0 1 1 0 1 1 0 1 0, etc. So this is one instruction in machine language program software. So as you can see, so this instruction is just an addition instruction. So for instance, if you have 2 numbers, 2 plus 3, the plus, you tell the computer, okay, so this is the plus that the computer sees this 1101, etc., and then understands it. Oh, okay, this is an addition operation. So I'm going to add 2 to 3. This is what the computer sees and understands. But for humans, for us, for computer programmers, it is very difficult to understand this and make sense of it, right? So that's why we're not going to use it. We are going to use some other type of programming language. So there is another type of programming language that is called a low-level language or an assembly language. So they are developed to make the programming easy. So compared to 1101 that you see, an example in assembly language looks like this. Add 2, 3, result. Okay. But now that we are able to understand this piece of instruction or piece of code, the computer doesn't understand it. So the computer needs a translator or an assembler that converts the assembly language instruction into machine code, into 1101. Okay. And a high-level language is actually, compared to low-level language, it's easier to learn and program, and they're more English-like. So for instance, so this one is an instruction. For instance, the area equals 5 multiplied by 5 multiplied by pi. So that's 3.1415 is a pi. And then there is a semicolon. So this is a Java code instruction because there is a semicolon at the end. Okay. It could be also C++, but in Python we don't have the semicolon at the end, this one. But in some other programming language software, for instance Java or C++, the end of an instruction is declared to the computer by the semicolon. Okay, so this is quite easy. So what do we do here? We are computing the area of a circle, and the radius is 5, and we radius multiplied by radius and multiplied by pi. So this is how we compute, write a instruction of high-level language. And the popular high-level languages are Java, Python, C++, C#, Visual Basic, etc. In this module, we are going to learn Python. Okay. So what is the distinction between the programming languages? So there is actually no formal distinction between high and low-level language. It is more characterized by the closeness of the hardware. So low-level language is closer to the hardware, computer hardware, than a high-level language is. So if we were to look at the interaction between the hardware and the software, in the low-level language, the interaction is direct with the hardware. But a high-level language needs other intermediaries to interact with the hardware. So that is the only basic distinction. And if you look at the steps, the number of steps or the intermediaries between the computer program and the hardware, so the low-level language, the assembly language is here. So machine language is also considered as a low-level language. So there is a direct interaction between the software, but higher level languages need some additional intermediaries to interact with the hardware. So a comparison is a high-level language is easy to use, but one drawback for the high-level language is that memory and speed optimization are handled by the compiler. So compiler is the intermediary between the high-level language and the computer hardware. So therefore it is less flexible. But a low-level language, although it is difficult to use compared to high-level language, the memory and speed optimization is handled by the programmer, so that's more flexible. But why high-level languages becoming popular? Because this memory and speed optimization handled by the compiler is no longer an issue. So in like 20 years ago, 30 years ago, this was a major drawback. But nowadays, because the memory and CPU power is getting cheaper and they are getting a lot faster, now the compilers are smart enough to perform memory and speed optimization so fast that, and they're becoming so cheaper that this drawback, this one, is no longer an issue. So that's why many people start to use high-level language. So let's say that we have a source code. A source code is basically the instructions or the computer program that we wrote. It's also called source program. So they're the programs written in high-level language. So we have this program, we have this instructions, right? So we have this program. This is the source code. And the hardware, before hardware to be executed, there needs to be a compiler in between, okay? Because the computer cannot understand the source code. We write them like English, like it's not 10110. So it needs to be translated into machine code for execution, okay? And the translation can be done by using another programming tool that is called a compiler or an interpreter. So an interpreter and a compiler, they are different in one critical sense, and that is an interpreter reads one statement or one instruction or like one line of code at a time, and then it translates it to machine code and it executes it right away. So if you have this, let's say 100 lines of code, so we have like, so these are the instructions, this is the source code. So the first line is translated and executed. The second line translated and executed one by one, separately and independently, okay? So this is how interpreter works. A compiler, on the other hand, it translates the entire source code. So this is the only difference between the compiler and an interpreter, that the compiler compiles the entire line, 100 lines, and then the conversion after the entire code is converted to machine code, then it's executed. So it's not one by one, it is the entire stuff all together, okay? And our computer, so we actually write the program. So user is us, we are going to be computer programmers. So we are going to be using some programs, application programs, such as Python. And before interacting the hardware, we need to execute our activities on the operating system. So for instance, if you open a web browser or a word processor, you need an operating system to be installed and running on your computer such that it translates whatever you're doing on the web or writing on the Word onto the computer hardware, okay? All right, so let's do a quick review of what we learned so far. So we are going to do a question and answer. It's going to be simple. I'll just read the question out loud, and then you can pause me, you can stop the video and then try to answer, because I'll move a bit fast. So please stop wherever you feel like, and then try to give your answer, and then run the video back again to see whether you answered it correctly. Okay, so the question, a bit is a sequence of 8 bytes, true or false? You can stop the video here and then try to answer. I'll give you the answer right away. It is actually false, right? Because a bit is either 1 or 0, whereas a byte is 8 bits. So this is a byte, and each one is a bit right here. So it is actually the other way around. A byte is the sequence of 8 bits. So that is false. Okay, second question. We can store data permanently in storage devices. True or false? The answer is true, right? Because the storage devices are to store the data permanently, right? Okay, good. Next question. Assembly language is a low-level programming language. True or false? The answer is, again, true. Assembly language is one of the low-level language, low-level programming languages. Okay. All right. Another question. Only numeric data is stored as binary. True or false? The answer is false, because all type of data, whether they're numeric or characters, they're all stored as binary code, right? For instance, we learned about J, capital J. It was like 110101, something like this. I'm just making up, okay? So it's not only the numeric numbers, 1, 2, 3, 4, 5, it's also A, B, C, D, E, also stored as binary. All right, another question. We can store data permanently in RAM. True or false? Here the answer is false, because as we learned, RAM loses the data when it restarts. So every time the computer starts from scratch, the RAM is empty. So we have the data stored in RAM temporarily, but in storage devices, the data is stored permanently, right? Okay. Another question. A high-level language is closer to hardware in terms of direct interaction than a low-level language. True or false? Here the answer is false again, because here it says it is closer to hardware than low-level language. It's actually false, because here it was hardware. Here we have our low-level languages, and on top we have the high-level language. So in terms of closeness, low-level language is closer than high-level language, right? So the answer is false. Okay, one final question, and then we are going to stop the second part. Which is the example of a code in machine language? So you have area equals 5 multiplied by 5 multiplied by pi, or 11001, or both or none of the above. The answer is B, is this one, right? So this is a high-level language. This is the machine language. Okay. If all is good, I'll stop the second part, and in the third part and the final part of the first lecture, we are going to introduce the Python, and we are going to learn how to install it, and then we will write our first Python program. Okay? So I'll stop this video here, and I'll hope to see you in the third part.